teamwork. We can do anything when we have teamwork.
So nice to have you three consultants here today to help me with the starting up my new company called GoFast. This company is about ride-sharing service. Since this service has been so popular and the demand in Chicago is also increasing, so I want to share a slice of this big cake. And I need your help to build a simulation model to figure out how to minimize customer waiting time and maximize both the driver's income.
So for this presentation, we will present the final deliverable for the revenue maximization strategy for a GoFast company's ride-sharing system. And first thing first, we want to make sure that the three main goals we learned from the first meeting correct and pertain to the project. So the first goal will be to reduce the customer's average waiting time. By doing that, we will create a better customer's experience and potentially increase the number of trips that we can complete. And secondly, we want to increase the driver's income, and drivers will be happy with a higher income, and it will attract more drivers to join the firm in the future, and potentially we will be able to grow our business. Last but not least, we want to increase company's revenue for the shareholders. And besides that, with a stronger performance, the company can attract more future funding in the future, which will be good for the future development of the company. And with those three main goals bear in mind, here is the methodology for our project. We will first make assumptions to clarify and simplify the system we want to model and build a constructed model based on those assumptions. And by running the simulation using those models, we will get output to analyze. And by validating and verifying the model based on those output, we can make changes and refine the models we just construct. And by doing this iterative process, we can finally get a model that's accurate and we are satisfied with. And with that final model, we can get the final output so that we can process it and analyze on it and reach the final conclusion and suggestions. So there are four main types of assumptions. The first one is the modeling, general model assumption. And the other three are about the random variable we use in the model. So for the modeling assumptions, we assume based on the company's data that the company have 30,000 customers and each customer use the app 6 times a week. And when calculating travel distance, we calculate it by Manhattan distance. And that's a really important point, that the average speed is constant and is not dependent on time or location. And lastly, we assume that for Chicago area, we mean a region with dimensions 30 minutes times 30 minutes. And for the pickup time assumptions, it's also really important that the riders and drivers are uniformly distributed in our region. And for any rider, when we assign drivers to that rider, we only consider driver within a square of dimensions 30 minutes times 30 minutes. And lastly, for the pickup time of each rider, we assume it is IID and also independent of location. And to calculate and to model the customer arrival time, we assume the customer arrival time follows exponential distribution with expectation always constant and independent of the time of the day. And to calculate the service time, we assume the service time for each user is independent of the growth size. And we also ignore the chance that several users are in the same growth.
Without the assumptions, we carefully investigate the entire system of ride-sharing service and simulate it into Sigma. As you can see, this is just a simple multi-server queue with a block event. First of all, a bunch of customer orders will received by our system, and after a certain amount of waiting time, customers will be picked up by their drivers, and the service will begin. And the service will be completed in a certain amount of time. An important point to mention is that if the number of customers in system starts to exceed like the number of drivers in our service system, all the upcoming orders will be blocked. In this model, we mainly use three parameters. The distribution for pickup time is calculated from our assumptions, which we then find out tend to be like the mean of a series in IID triangular distributions, and the customer arrival time is also assumption based, and we figured out to be an exponential distribution with rate of lambda equals to 0.2976. And for the service time, we keep feeding a lot of data into different distribution models, and finally got an exponential distribution for this data. Unfortunately, after we applied the validation and verification process for our model, we found some possible sources of error for the simulation. For the pickup time, the distance distribution between customers and drivers can at the city center and the edge of the city can be different. And also, the drivers and customers cannot be uniformly distributed everywhere. What's more, it is impossible for the drivers to be on a constant speed all the time. For the customer arrival time, actually the demand is changing over time instead of being constant. And for the service time, we actually use in a appropriate source of data data sheet from actually a taxi company, and we only use 1 month of data, so the data range can be pretty limited. Finally, for the driver's working time, I mean, it is just impossible for all the drivers to work the same amount of time every day. So that so all those uh, errors are likely to influence or result a little bit.
Finally, based on the data derived from the simulation model, we processed and analyzed the average customer wait time and driver's average hourly income to make a conclusion. According to the analyzed data, we can draw three different graphs, which includes average profit versus driver, average waiting time versus driver, and total profit versus driver. Based on these three graphs and data, there were several conclusions we can make. The first one is that when total drivers is around 3,100, total profit approaches to maximum and waiting time becomes short. So the first suggestion is that the optimal number of driver should be around 3,100. The second conclusion is that when clients in line become large, we use the rule that first come, first serve. So the waiting time will become longer. The second suggestion will be that when clients in line become larger, we should encourage more drivers to be on the road and dissuade clients from looking for rides. The third conclusion is that the range of commission fee rate we can choose is from 20% to 46%.
Side by side, we can reach our dreams, 'cause nothing's impossible when we're a team.